The ninth question is an important question in the sense that it involves solving system of equations in vectors. Now in these type of questions you can go with the standard way also, but it is always advisable to think about what is written geometrically. It is always very helpful if you think about it geometrically to deduce something and then use that extra information to solve the question, like we'll do it in the first part. We have to find out R vector which satisfies R vector minus C vector cross B vector is equal to 0 and R vector dot A vector is equal to 0. Let us solve it here. From the first part, it is given that R vector minus C vector cross B vector is equal to 0. Now since the cross product of these two vectors is 0, therefore these two vectors must be collinear. Therefore we can write R vector minus C vector is equal to K times B vector. So we have deduced one extra equation. You could do this only because the cross product of these two was equal to 0. So whenever in future if you have something like this, you can always write it like this. Now the question will become very easy to solve. We can write R vector is equal to C vector plus K times B vector. Now with the extra information, the other information given to us is that R vector dot A vector is equal to 0. So let us take dot product on both sides to get R vector dot A vector is equal to C vector dot A vector plus K times B vector dot A vector. This is equal to 0. A dot B is not equal to 0 and R vector dot A vector is given to be equal to 0. Therefore we can write K is equal to minus of C vector dot A vector upon B vector dot A vector. B vector dot A vector is coming in the denominator. That is why this has been given to be not equal to 0, so that we could divide the whole thing by B vector dot A vector. So we directly get the value for R vector by substituting this value of K over here. That is R vector is equal to C vector plus C vector minus of C vector dot A vector upon B vector dot A vector times B vector. So this comes out to be equal to R vector is equal to A dot B times C vector minus C dot A, or rather A dot C, it's the same thing, times B vector upon A vector dot B vector. So we get the answer for our first part for R vector as R vector is equal to A vector dot B vector into C vector minus A vector dot C vector into B vector. This is not cross product. This is a scalar which is being multiplied to a vector over here upon A vector dot B vector. Now let us solve for the B part. This is our answer for the A part. Let us solve for the B part. In the B part we have R vector cross A vector is equal to B vector and we have been given R dot A is equal to 0. Now to solve this question, what we can do is, let us take cross product by A vector on both sides. This is equal to B vector cross A vector. We have taken cross product by A on both sides for this equation. This will give us R cross A is equal to B cross A. This can be written as R vector dot A vector times A vector minus A vector dot A vector times R vector is equal to B vector cross A vector. Now R dot A is given to be equal to 0. Therefore this quantity becomes 0. Therefore we have R vector is equal to B vector cross A vector upon minus times, or rather minus of B vector cross A vector upon A vector dot A vector. This is equal to A vector cross B vector, because A cross B is equal to minus of B cross A upon A vector dot A vector. So final answer for the B part comes out to be A vector cross B vector upon A vector dot A vector. The idea behind taking a cross product was that I thought about it in this fashion, that I would get a term of A vector dot R vector which would cancel out, and because because we had the given information that A vector dot R vector is equal to 0, so this prompted me to think that let us take cross product by A vector on both sides. So thus we get a final answer for the B part as A cross B upon A dot A, and for the first part as A dot B into C vector minus A dot C into B vector upon A vector dot B vector.